At the end of the previous video, I asked you to differentiate 2 to the power of x and also 3 to the power of x. So in the case of 2 to the power of x, if you start out with y equals 2 to the power of x, you would blah 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 get to dy by dx equals this thing here. Okay. At the end of the previous video, we got to this stage here. Now, when we get to this stage here, we're at a stage where we don't fully understand this block here. So we would, well, this here is a limits problem. So we would translate this into a graph. So if you're trying to solve this, you can translate this into a graph. So if you get a graph and plot, well, translate this bit first into a graph problem. So if you look at this here, if you plot a graph of y equals 2 to the power of x minus 1 divided by x, and then that will then give you this. That will then give you this this graph here. But then if you want to work out the limit as h approaches 0, that's the same as you doing this. That's the same as you looking at this graph and then starting from here and then slowly approach 0 here. That's what it means to take the limit as h tends to 0. So you would take the limit and then approach 0 here. So the limit is going to be right here. So that's somewhere here. You see, dead on 0 is undefined. So what we do is we nudge this point just to the right or the left. It doesn't matter. If you nudge that to just to the right, if you nudge it just to the right, that will then give you this. Okay, that will then you nudge your graph just to the right, it will then give you this. Okay, so hang on, let me start again. So at the end of the previous video, I asked you to differentiate y equals 2 to the power of x, and then it was blah blah blah, and then we get to this stage here. Okay, and then this bit here, we don't fully understand this bit here, so we would turn it into a graph looking like this, and then take the limit as h well, in this case as x tends to 0 here. Okay, so that would then give us this point here. We ultimately want to know the limits here, and the way we do it is there are lots of ways of doing it, but the way we did it was to nudge this point just to the right or to the left, and then that would then give us this value here. So this is our value here. Okay, so we can then put this value here into this box here. That will then give us our dy by dx. So what dy by dx? So what goes in here is 0. What is it? 0. This bit here, 0.696. 0. So dy by dx equals 0.96, and this here is just an estimate. Okay, so hang on. Forgive me. Let me repeat it one more time. So differentiate y equals 2 to the power of x. Blah blah blah. Many steps in between, and then we get to this stage here. So dy by dx is this thing here. We don't really understand this bit here, so we turned it into a graph, and then we managed to work out this block. And this block here gave us 0.6 blah blah blah. So it's basically us getting this and putting it into this block here, because this limit here is this bit here. And remember, this block here is just an estimate. This is just a method of this 0.696 is just an estimate. It's not precise. This is not the true limit yet. Well, we don't know what it is yet. We don't really understand this thing here. We are just at the moment just playing around just to get the feel of this thing here. We don't really understand this bit here. We are just playing around just to investigate this thing here. Okay, so dy by dx equals this thing here. So when given y equals this, dy by dx is this thing here. So what that means is that if you look at the graph of y equals 2 to the power of x, it would be this. It looks similar to this here is our y equals 2 to the power of x. So this is our graph, y equals 2 to the power of x. Suppose you want to know the gradient at x equals 2 here. Suppose you want to know this gradient here. What is that gradient at x equals 2? So starting with this graph, if you want to know the gradient differentiate it, dy by dx equals this here. And remember, this is just an estimate. Okay, so if you want to know the gradient at x equals 2, dy by dx is given by this thing here. But because you want to know the gradient at x equals 2, you then put it into this x here. So that will then give, so that's this 2 here, you put it into here. Okay, so it's going to be this weird number times this thing here. And then the gradient at x equals 2 is given by this. Okay, so at the end of the previous video, I asked you to find out 2 to the power of x and 3 to the power of x. Now we've done this, so now let's do y equals 3 to the power of x. So it's the same process here. If you start with this, blah blah blah, many steps in between, you will get later on. You will then get to this stage here. So dy by dx is given by this. We don't fully understand this block here, so we would turn this limit problem into a graph. So we would plot a graph of y equals 3 to the power of x minus 1 divided by x. So if you plot that graph, it will then give you where is it? Yeah, well, I didn't do it, I forgot. But then turn this into turn this into a graph problem, and then find the limit. And it turns out that, oh yeah, so this here, sorry, this here is y e. So this red line here is y equals 3x minus 1 over x here. So this red line here, this is a graph of the red line here. So if you want to know this box, hang on. If you want to know this box here, you would turn into a graph, plot it, it would look like this red line. But because you want to know the limit of this thing as h tends to 0, when you translate it into a graph, it's really you getting the limit as x tends to 0 here, in this case here. So if you want to know this bit here, you would look at the graph, and then basically you would approach 0 here, approach 0, and then you would start here and approach 0 here, and then that would then give you this. That would then give you this. So now if you put this value into here, then that would be 1.105, and again this is an estimate. Okay, so dy by dx of dy by dx of this thing here is 1.105 here. Okay, so hang on. So y equals 3 to the power of x. If you differentiate it, it will give you this. dy by dx is roughly this thing here. Okay, yeah.